Hey, that's looking pretty good. G'day pals, welcome back to a new video. Today, we're going to be covering implementing the walking animation we've covered in the last two videos in Unity. So this is going to be a very straightforward code tutorial. I'm going to assume that you have some very basic knowledge in C# and Unity. If you can read any code at all, this is for you. It's not an advanced tutorial, and I'm not going to go into the most efficient way of solving this problem. I'm just going to try to keep the code nice and intuitive, and I'm going to be explaining everything that I'm doing as I go. So let's kick straight off, shall we? Here we are in a blank Unity project. So I'm assuming you've just gone into Unity, you've gone into a 2D project. If you've made like a 3D project, just make sure you've got this 2D clicked and that you aren't showing the skybox. And that's basically a 2D project anyway. So what we're going to do is come back to our animation. If you've gotten this far, this is where I left you last time. So you should have south, southeast, east, northeast, and north animations, right? That's what we've done up to this point. And now we're going to take these and put them into the game. The first thing that I'm going to do is go to my project and put my Sprite file in the project. Okay, Sprite files are very small, so they're not really going to bog down the project if you leave the source files in here. The reason why I want to do this is because I'm going to be exporting all of the files in here. That means that any changes we make to the animations, if we re-export them, they'll update automatically in here because the PNGs will be picked up by Unity and they'll just auto refresh. We won't have to keep dragging files into the project. So here we are in the file. I want you to take, you can just press file, we can go export, and then we want to take the frames for each of these. So in this case, we're going to go south, we're going to export that, and then southeast, east, northeast, north. You can do it as one big file if you want, if you're happy to keep track of it. So if you can grab everything and just say like all frames, visible layers, this will give you the whole thing as like a horizontal strip, or you can do by rows as well. Since we know this is like a 6-frame walk, we can do it by rows with a fixed number of columns as 6. The only reason why I wouldn't do this, and the reason why I like to keep things nice and separate it into different files, usually with my like 2D projects for side-scrolling games, is I might decide to add frames later. Now in this case, we're probably not going to do that because you're following my tutorial. So let's just say we can export this as one big, 6x6 grid of sprites. Just so you know, when I did this in prep, I used a little tags to sheets script, which I've linked in a previous video. The video is called How to Turbocharge Your Workflow. And this will effectively just take all of the tags and then just export sprite sheets for each of them individually. And that way you don't have to track the grid columns and width. It'll just do it. So now we can see all of those things we just exported are in the project directory. And I think we'll use the 6x6 just because that's what I said we'd use. Now we need to be careful and make sure that we have the right ones represented here. So we're going south, southeast, east, and then we've got, I think this is northeast and then north. Yeah, so that's fine. They're arranged quite logically, thankfully. So the first thing that we want to do is change the import settings of this. To do that, we're going to open up our inspector here. I'm just going to drag it into view so that you can see it. And I want to make this set to multiple. So it's going to be a sprite sheet. I want to be able to set the quality for compression to none because I don't want to change any of the way the pixels are rendered. Okay, we don't want to blur them. We're going to set this to point filter, no bilinear filtering, none of that. So we can just pop that in there and put the inspector back where we found it. Now we can go to Sprite Editor, and that's this guy here. We can move this out of the way. And this is our sprite sheet. It doesn't have any slices yet. We have to do that manually. So we're going to click Slice. We're going to go Grid by Cell Size. And by default, this is 64 by 64. That happens to be the exact size of the sprite that I've been working with. So all I have to do now is press Slice and then Apply. Now we have 36 lovely sprites. Okay, so now we can set up the scene a little bit further. What I want to do is basically just put a camera in here and create a character that we can control around. So let's put a camera in. Let's not draw the skybox, and let's make sure that this background type is set to solid color. Beautiful. We're going to make this an orthographic camera, and orthographic means that we don't have any perspective. So things that are further away won't be drawn smaller. It's better for 2D games. We're going to make this 1.8. That's how I like to scale my games. That's the size of the character in this scene. It's a reasonable size. So we're going to call this character. Now, what I did was drag in a sprite and it automatically set up a game object for it. You can do that if you want, or you can just create a new game object by right-clicking and pressing create empty. Say character. And then we want to make sure that our position is all set to 0, even on the Z axis. That's really important because if this is too far behind the camera won't see it. Then we want to do a sprite renderer. And we can drag any of these in here to grab the sprite in. So that's the same thing as just dragging it from the bottom. So the next thing we want to do is add a rigid body. I'm assuming that you're going to make a game out of this, or that you want to take this a bit further. So I'm going to freeze rotation. I'm going to turn gravity scale to 0. I'm also just going to make it kinematic. Kinematic means that we won't really be using gravity, but we're going to be effectively forcing the velocity ourselves. We're not going to use outside forces to determine the velocity of the thing. So that means, it basically means move when I tell you to move, not any other context. So kinematic, freeze rotation, and that's good to go too. I've also seen some people say to set this collision detection to continuous, which is totally fine. And also never sleep. These are more for high velocity collisions, making sure that the character doesn't go through walls, that kind of thing. But these aren't really important for what we're going to be doing today. In fact, I don't think we'll even do collisions today, but we're just getting the character to walk. So we're going to add a component and we're going to make a new one here. This is going to be called top-down controller. Okay, you can just hit new script and then add, and that will create a new script. So top-down controller. We can double click this to open up our text editor. In my case, I'm using Visual Studio Code, VS Code for short. Visual Studio comes with Unity if you're on Windows by default, so VS or VS Code are both fine. I'm also using some custom code formatting here, so I like my brackets on the same line as the thing that they are starting. So you may see yours like this, mine are like this. Doesn't make a difference. It's all the same. Okay, so now we can get started. The first couple of things I'm going to do are bring in the rigid body and the sprite renderer into the script. I'm going to make sure we have spaces for those. So the first thing is rigid body 2D. Make this public and call it body, and then a public sprite renderer and call it sprite renderer. I like to call it sprite, but that's a bit silly because it has a property called sprite on it, so I end up saying sprite.sprite. Anyway, now we're going to think about how to bring in our sprites. If you are making a really big game and you're going to spend a couple of years on it, you definitely want to expand this functionality out into creating a scriptable object-based animation container, right? We're not going to be using the animator today. I'm going to go super simple. So this is going to be great to get you started. Down the line, you're going to be extending this out into something different, but I want to avoid Unity's animator plugin for now, and I want to avoid scriptable objects. So we're just going to get the character moving, and we're going to be selecting the sprites manually. So we need some container for the sprites to put them in here. What I'm going to do is have 5 different lists, one for each of the directions, and we're going to select the frames from those lists here. So I'm just going to say public list of sprite, and we're going to call it n sprites. That's north. That's going to be our little convention here. So we've got 5 of these. We've got north, northeast, we've got east, we've got south, east, and south. Okay, so that's good. A couple of other things that we want before we get started. We probably want to do a few variables here, like public float walk speed. And we probably want frame rate. That'll be good to start us off. We'll be adding to this a little bit later. As we're going to be referencing these two things, they're not going to be tied to the script by default. The way to do that, if you just have public set here, is to actually drag them in. So if you haven't done that before, I'm going to show you how to do that now. Basically, now all of our properties appear here. We're going to take body and sprite renderer from the game object and just drop them in. So body goes into body, sprite renderer goes into sprite renderer. And from here, I'm just going to drag this out so you can see it. We're going to grab our sprites and put them into these little buckets. Okay. So first, I want to grab all of the ones that face north. That's this 6. And this is the reason why you might want to do it into different sprite sheets, because it gets a little tricky to, visualize which ones are which. So these are east, these are northeast. These 6 are straight east. So north, northeast, east. And then we've got these 6 being 1, 2, 3, 4, 5, 6. Southeast, and then this 6 is south. Perfect. I just want to make sure that you have these set correctly. So your sprites, make sure that these numbers are ascending as they go down. Don't do what I just did and select them backwards and then drag them in, because they'll be reversed. 23 will be at the top and 18 will be at the bottom, and vice versa. So make sure it's 0, 1, 2, 3, 4, 5, not 5, 4, 3, 2, 1, 0. I'm going to set walk speed and frame rate to 1 and 4 respectively, or 6 respectively, just to give us something. And then that is good to go. So we can save that. Click on our character again. And those should all be the same. So what I did here was I right click and press properties to get this window out. And this means that if we click something else, that doesn't get lost here. Now we can actually just set these and not worry about the selection, hiding the place where we're trying to put all of our content into. We want to set up our inputs in the project settings. We're going to use the default input manager first. Later on, if you want to use a different input system, that's fine, and this will be compatible with that. But Unity's out of the box one will work. So this will do things like combine if you've got a joystick on a controller, or the up, down, left, right keys. It's got a bunch of defaults to essentially just like map those so that we don't have to map them by hand. The only thing that we want to make sure is that this is called horizontal. This is a default. We've got a horizontal and a vertical axis. And we want to make sure our sensitivity and gravity are set to like 100 each. This means that we want this to feel like when we press a button, the character's moving at max speed immediately. We don't really want acceleration or deceleration. So just set gravity and sensitivity to 100 on both the horizontal and the vertical axes. Okay, so we're going to say input dot get access, and get access as opposed to get access raw gives you a kind of treated version of the input. So if your controller has like a dead zone, it will account for that. If it's got like a bit of a wonky desynced, like a drift, it might account for that too. So get access raw is if you just want the value that's coming out of the controller, but get access is usually a little cleaner. So I'm going to make 2 more variables. These are going to be private. This is called float x and float y. We could make this a vector. So we could say vector to direction if we want. We'll say direction equals new vector 2. And we're going to put 2 of these get axes inside of it. So we're going to take the x and the y. We're going to call this horizontal, and we're going to call this vertical. Okay, so our direction vector tells us where the character is moving, and get axis horizontal and vertical tell us what the joystick's doing, basically. Now we want to map this to the velocity. So we're going to take the body dot velocity, and we're going to say equals direction times walk speed. That's it. Super simple. We may want to normalize this first. I just want to explain very quickly why we won't just take the X and Y axes directly. It's very simple. Think of it this way. If this is your Y and we go from 0 to 1, then holding up puts, the value here, right? It's at max. If this is X and it goes from 0 to 1, and we hold the max value, that goes to here. Okay, so that's fine. But if we have both of them and we have the y, all the way up and the x all the way across, that's going to put us here. This length is longer than this length. So you could say the hypotenuse of this triangle is longer than any of the sides, right? The longest side of a triangle is always the hypotenuse if it's a right angle triangle. And if we're using this to determine walk speed, this will be faster than this, right? We'll be going faster if we're moving diagonally. So what we really want is for this to be like a circle, right? We really want this so that the radius is always 1. Okay, so that max speed gets us to here if we're holding y all the way up and x all the way up. And that's what normalize does. It maps the length of whatever the number is between 0 and 1. So in this case, because we're setting velocity, direction is just a direction. In fact, if we want to think of it that way, we should probably normalize it earlier so that the name direction really means what it means. Okay, so it's normalized, and we do this every frame, right? Because this is inside of update. So every frame we get the direction, and then we're going to set walk based on direction. Okay, that's all we need to get started. If we, hit play now, we should be able to use the arrow keys to get around. And there you go. Now we're walking around the screen very slowly because we set our walk speed to 1, but it totally works, huh? So let's have a look again. We can up the speed if we want to maybe like 2. And now we're moving a little faster, and we're not moving any faster in any particular direction. Nice and clean. The next thing we want to do, what might be really easy, is to just make the character face the direction that we're holding. So we're going to say, we're going to like handle direction. And in this case, what I think we should do is just flip the sprite, depending on if we're holding left or right. Sprite renderer dot flip x. That's what we're looking at here. So we're going to say if sprite renderer dot flip x. So if we are, in fact, let's pseudocode this out. What that means is just type it out, what we want to happen. So if we're facing right and the player holds left, flip. If we're facing left and the player holds right, flip. Those are the only 2 times we want this to happen. Like if we let go of the controller, we don't want the character to flip. We only want to flip if we're facing the opposite direction to the way that we're moving. Flip X means if it's normally facing right, face it left. So if we're not flipped and direction.x is less than 0, sprite renderer.flip x equals true. So direction x is less than 0 means that x is going negative, and negative is left in our world space. So we're going that way. That means that we should flip the sprite. Else, and we're just going to do the same thing basically for the other case. So if we are flipped and our direction is greater than 0, then it's false, right? We don't want to flip in that case. We want to flip it back. And that's it. So we can turn this into a little function if we want. We can call this handle sprite flip. And then grab all of this code and say void handle sprite flip. And there we go. I'm sure there was actually a faster way to do that. I think you can just take a bunch of code and then just put it inside of a new thing, but that's the way I'll do it. So now that we have this, we should be able to hit play and have the character turn around when we face left. Let's see if that works. Nice. And when we let go, nothing bad happens. So the character's only flipping when we make it flip. Great. Now, for what we really came here for, we want to be able to select sprite or set sprite. So let's make another new function and call it set sprite. And what we're going to do is I'm going to keep it really simple. I'm not going to use any crazy math to determine like which of the 5 animations we've picked. I'm just going to use hard logic, and I think you'll appreciate this because it's easy for you to understand later. So we're going to say if direction.y is greater than 0. So that's up, right? So if we're trying to move up, do a bunch of stuff. else if direction dot y is less than 0, we're going to do something else. Else, that's neutral. So we'll go, this is up or north. This is south. And this is neutral. What I want to do here is assign a reference to the sprite list that we're going to pick. So I'm going to say list of sprite. Remember, list of sprite is what we have up here. So we have 5 lists and I want to pick one. So I'm going to call this like, or selected sprites, let's just say, equals null for now. So if we're going up and if direction.x is greater than 0, so we're going up and we're going east, then selected sprites equals NE sprites. And we're not going to just pick east per se. It's more like east or west. Okay. And the way that we do this is we don't just check to see if the direction of x is 0. We want to check to see if the absolute value is greater than 0. So absolute value means either it's going to the right, or it's going to left, or it's negative, or it's positive. If it's -5 or +5, this will return 5. We just want to know the magnitude or the size of the number. It doesn't matter if it's in the negative direction or otherwise, because we're handling east and west with the flip, remember? So we really just want to know the absolute value of the direction, as long as we're not holding nothing on the x-axis. Otherwise, if we are holding nothing on the x-axis and we're holding north, then this is straight north, so neutral x. Then selected sprites equals north sprites, right? So we're directly holding north if we're not moving in a direction with the x, and we are moving in the upwards direction with y. And then we're going to just copy this and paste it. So it's the same thing, but now for south. So this becomes SE sprites and S sprites. We only need to know if we're going in a direction with X or not. So if we're holding a direction in the X axis, then this is east. So we've got northeast, north, southeast, south, and then east, and that's it. Now I want to configure this slightly differently. I'm going to call this get sprite direction, because I think that it's important to note whether or not we were actually moving, because later down the track, you'll probably want to implement an idle frame here. So let's call this get sprite direction, and let's return a list of sprite. Okay, so then we're going to return at the end of this selected sprites. Okay, that's what this is. This is the return value. So we're just going to send this back to whoever called it at the beginning. So back here, get sprite direction, we're going to say list of sprite direction sprites equals get sprite direction. And then we're going to say if direction sprites is not null, so it's null if we're not holding anything, else we're going to do something else. So we're holding nothing, input is neutral. So this is what happens if we're holding a direction. This is what happens if we're holding nothing. I guess like the first thing we can do, if we just want to like play this and just see that something's happening, is to say sprite renderer dot sprite equals direction sprites at 0, right? This means give me the first sprite in the list that we picked. So this is the list that we picked from this. And we're just going to say, just give me the first one. Arrays and lists, everything in computers counts from 0. So 0 is just give me the first thing. And this should be functional. Fingers crossed. So now we're moving in whatever direction we face. Perfect. Stardew Valley, here we come. Obviously, the next thing you want to do is determine, like, how do we make this character walk? We want the character to animate. And to do that, we're going to need one more variable. We're going to call this idle time. Okay, idle time is going to be a number that is set to our current time whenever we're not doing anything. Because in order to know what frame to pick when we're walking, we want to know how long we've been walking for. Okay, essentially it's like walking is going to be like an animation that we're playing. And if we're playing an animation, we need to know the duration and we need to know how long since we pressed play. Idle time equals time.time. Okay, so that's really important. The next thing we want to do is determine our duration. So how long have we been walking for? Or like play time is another way you could think about it. And that equals time.time minus idle time. So this is the distance between the idle time and our current time, or how long has it been since we've been moving, is a better way to think about what this is. Float frame equals the frame that we're going to pick based on the playtime. This needs to be an integer because we only have index 0 or 1 or 2 inside of those lists. We need to be able to pick which one. So we're going to say we're going to pick the frame, and that's the sprite that we need to pick. So the frame is playtime multiplied by frame rate. That means, you know, if it's been 1 second and our frame rate is 6 frames per second, we want this number to be 6. Okay? There's an issue here, of course, which is that if this number goes beyond the amount of frames that we have, we want it to loop back around. Otherwise, we're going to be trying to access a frame that doesn't exist. Like frame 7 doesn't exist. So we can't have this number be 7. It has to be a number that's inside of our list. And the way to do that is to use the remainder. So we call this modulo. That's what percentage means in maths for computer science. And we want to take modulo the amount of frames that we have. And in this case, we need to be specific. So we can say direction sprites dot count. That's how many sprites there are in each of our lists. And we want to make this an integer as well. Right, because this could be a floating point number as well. And make sure we wrap the entire right-hand side of this thing so that this is called casting. This makes sure that whatever's here on this side, inside the brackets, is an integer. So the way modulo works, I'll be really quick to explain it for those of you who don't know what it means. If we have a number like 11, and we have our number 6, that's how many frames we have. If you have our 6 boxes, like 1, 2, 3, 4, 5, 6, and then we'll put a break here and say 7, 8, 9, 10, 11. The modulo is on this side. So it's the amount of frames remaining after you divide this by this. So 11 over 6 goes once, right? We get 1 and 5 over 6. Right, that's what this is, because we get 6 and then we get 5/6 remaining. If this was 12, we would get 2, right, which is no remainder, which means that our frame should be frame 1 or frame 0, right, because the remainder here is 0. So that's what modulo does. All it does is basically takes the left-hand side of this like 2 remainder whatever, and or however many, and just tells us how many left over. And that's the frame. Because what this is, I mean, it goes from 0 to the number of things that there are, right? This is how many frames there are. So the remainder is always going to be less than the number that we're dividing by. So it's great for choosing frames in an animation. So we could call this like total frames if we really want. And we could cast this to integer if we want as well. And then we don't need this. We can make this all, this will be fine, hopefully. If we make that an integer. Yeah, cool. So maybe that's a bit more clear for you. So time since we started walking, total frames since we started, current frame. Okay. And that's it. If we stop walking, then this will reset the counter to the current time. And as long as we're walking, as long as the direction that we've picked is not null, then this should be ticking up. So, shall we have a look? Hey, there we go. There's our walking. Let's see if we can get this a little tighter. I think the character could be walking at maybe a frame rate of maybe 12. And we could go at like 1.2 meters per second. Hey, that's looking pretty good. So now that we've got that going, just let's make sure that we're being good boys and girls and putting this code into like some kind of like select sprite function. So set sprite. Boom. And there you go. There you have it. That looks great. So if we want to do collisions very quickly, we can set this back to dynamic. We can create a 2D object like a square or something like that just to test. Put it in the scene. Make sure its Z-axis is on 0 so we can see it. And that looks good. Give it a box collider 2D. Good, good. Go to the character. Give it a box collider 2D. And then edit the collider just to make sure that it's, you know, where you want it to be. I always like to give a little bit of extra space for the character so that we can see them running into the wall. Very good. Save that. And then hit play. And hey, very good. So that's your very first top-down 2D level, all by yourself. Congratulations. Thanks for watching. I had a blast. If you want to see more content like this, let me know, I guess. I don't know how much programming stuff I'll do. Just as an aside, like I really enjoy doing this kind of stuff, but there are so many of these kinds of tutorials around, and I don't think that I'm qualified to like explain how to do like the best way to do all of this kind of stuff. I'm much more comfortable giving like one-off little examples like this, because there are real software engineers who watch my my stream and my YouTube channel, and they would be happy to correct me if I made a big mistake. So I think with something as simple as this, like you can't really go wrong. As I said, like even this isn't the most ideal way to do this. You know, you would probably want scriptable objects and animation files, but if you just want something getting like up and running, then I mean that was what, 5 minutes? It was a bit longer than that, but that's it. Thanks for watching. As always, I've been Adam. You've been the Pixel Pals. I'll see you in the next one. Hey pal, thanks for watching, and thanks most especially to the patrons and Twitch subs who support this channel and my game dev project Insignia. To find out more, click the links in the description below. And if you like this video, tell YouTube by clicking the like button, and then YouTube will tell me, and then I'll make more videos. That's nice. Thanks again, and until next time.